AI never sleeps. We're tuning into a special episode without Ash today, so you all can listen to me stutter and trip over my words without anybody to save me. We do have a special guest star today, Disto Protagonist. Todd, care to introduce yourself?
Yeah, Disto Protag is my online name after everything went censory back in 2020. I just realized somebody has to be a protagonist in this
Dis-
dystopian world, so that's what I use online. But yeah, I'm a data engineer and billiards enthusiast, and I'm curious about stuff. And I usually reach out to you when I have questions about AI.
and this time
And
around, you reached out with a really interesting question that I'm very enthusiastic to answer.
so for me to actually make sense of any of this, I'm just vaguely familiar with LLMs, and I don't have like I've read some of your posts, and it just goes you talk about neural networks or AGI in general, and this has been over the years. I'm like, well, it's clear you've done the research and have dug into it and really understand what's going on in the background. And for me, because I've developed applications and things that I've had to use my own intelligence to basically try and tease data out. So if you can explain to me just if you can give me kind of an overview of just how these models work. They use a lot of compute, and that had always been that's always been a barrier in terms of development without, in the old world in the last 20 years or so. It's just been you have to kind of massage stuff so that you're not chewing up a bunch of processing to get answers out of large data sets.
Well, they
So
use a lot. They use a lot of compute, but the way that they were developed was out of models that you could run back in the day on your own desktop machine or on your own workstation. And of course, they've evolved over time. Part of the reason why LLMs have started to make such a breakthrough is because OpenAI observed certain scaling properties of a new kind of neural network architecture called transformers that warranted in more and more computing power. So they weren't the first to throw just buttloads of GPU power at these things, but the real innovations were algorithmic rather than hardware based. GPUs became widely available and got really, really powerful, partly because of the needs of computer graphics in video games, but also ultimately during the crypto boom. That's when these graphics cards got to be used as massively parallel processors. And after crypto crashed, we had a buttload of GPUs all over the market. And you know what else you can do when you've got a lot of parallel processing at your disposal? You can run neural networks. So these things kind of happened at the same time. But really, if you were using the kind of neural network architectures that were popular back when I was in college, all the computing power in the world wouldn't do anything for you. There's this joke of like, I've taken a pill that's increased my brain 100-fold. So are you smart now? I'm stupid faster.
yeah,
So,
right.
you
Flowers
know,
for Algernon, right?
Right. So the point is that, like, without the right algorithmic backup, all the computing power in the world won't do squat for you. So it was really the innovation of transformer architectures, which is a specific wiring
Explain that.
pattern for neural
Okay.
networks. So neural networks have been around for a very, very long time.
Can you unpack that a little bit for me, the neural network part of it? It gives me an image of mimicking the brain,
Yeah.
mimicking what we've discovered in the brain. I don't know really anything about neurology. What I've wondered and just haven't had the bandwidth to go really down to discover it on my own is in terms of the intuitive process. So like if I ask Grok something, it infers things from what I ask. So I can ask it imperfectly. And in the early days of Google, you had to be pretty specific with your search terms. And you learn that you couldn't ask Google a question. You just had to put in several different keywords and then go sift through all the results, that it had indexed with those keywords in it. You had to go sift through it. And they had some algorithm that ranks them, so on and so forth. But now you can ask it a question and you can just ask a question, like how, where did we get that leap, I guess, in the LLM, the leap from, just the plain text and it searching on a text string to knowing, I guess, to I don't, what appears to be knowing.
This was the real insight that Alan Turing had and why he formulated the Turing test. The verb thinking or the verb knowing is really loaded, right? We want to think that there's something special about what the human mind is doing. But at the end of the day, the tests that we give a human being to determine whether or not that human knows something, this AI passes those tests. tests.
Right.
So you can say that the AI doesn't actually know a thing, it's merely mimicking verbiage. But the thing is that when we give a human student a verbal test to determine whether or not they know that thing, if they pass that test, then we say that that person knows that thing. So if this AI is doing that exact same
Mhm.
operation, then it becomes extremely cherry picky to claim that, well, when a human does it, then it's knowing, but when an AI does it, it's not.
But a lot of the LLMs that it's based on human knowledge, right? Is there any original knowledge?
uh,
Producing are they producing novel concepts or novel ideas from the base of human knowledge? I guess that would
They,
get
they,
at what I.
they absolutely can. In the math community, you see a lot of modern mathematicians that are using AI as a tool set by which to find novel solutions to previously solved problems or to solve problems that humans haven't found on their own. So there actually are numbers of mathematical papers that have been coming out, none that are written by an AI by itself. As far as I know, nothing prominent anyway, but
Mhm.
many in which the AI was a major tool that the mathematician used for discovering novel truths.
So truth is, I think truth is an important concept there, and mathematical truth that like everything starts with some premise, right?
Right.
It starts
It's not accurate to talk about mathematical truth. You can talk about
right,
whether or not a mathematical argument is
but it's
properly formed.
axiomatic.
What?
Right.
Yeah,
It's
you can talk
axiomatic.
in math. You can say that something is sound, but you cannot say that something is true.
Right.
Trying to determine truth in the real world runs against falsifiability and the induction problem.
From faulty premises, your logic can be sound, but your end result, is that what the induction problem is?
No, the induction problem basically means that past performance cannot guarantee future results. You can watch the sun rise in the east a trillion times. That doesn't necessarily mean that it's going to rise in the east on day a trillion and one.
But it's a highly probable.
Yeah, I mean,
It's likely to.
but
It-
probability itself is a loaded term. Like, if you know of some factor that might cause the Earth to suddenly start rotating backwards the following day, then the probability is very high that the sun will rise in the west the following day. And
and if the turtle upon which the Earth rests turns, then
exactly, if it sees some sexy turtlet wandering in the other direction, it'll
it turns and oh wait, what happened to the
exactly.
sun?
Listen, we all know that there is no such thing as the sun anyway. It's merely a reflection inside the hollow earth that we see as an optical illusion.
It's a hologram. It's projected on us.
Exactly.
But in terms of the language model, so the question I asked you was they can be corrupted with 100 words or 100 questions, or like
250
they could be
documents.
250 documents
Right.
can corrupt an LLM.
Hey, editing time, Mikhail here. For those of you listening in purely on audio, the paper that we're talking about is called Poisoning Attacks on LLMs Require a Near Constant Number of Poison Samples. It was submitted to Arvix on the 8th of October 2025. This new study is a collaboration between Anthropic's Alignment Science team, the UK AISI's Safeguards team, and the Alan Turing Institute. Just a few excerpts from the abstract. And I quote, "Poisoning attacks can compromise the safety of large language models by injecting malicious documents into their training data. Our results suggest that injecting backdoors through data poisoning may be easier for large models than previously believed, as the number of poisons required does not scale up with model size." On the face of it, it certainly sounds like scary stuff, which is why Todd reached out. Let's delve into what it really means.
250 documents
Right.
can corrupt an LLM. What's important to me to understand your answer to that is understanding you've got these neural networks that have some kind of human interface heuristic or some kind of understanding. But can it imagine something? What comes to my mind is a lot of these, like some of these movies that the world based on it is kind of sick and twisted. The Cube, or the one where I don't know, some of these horror movies where I won't watch them anymore because it's like I don't need that in my brain. I don't need that. But somebody imagined that up. Somebody conjured
Right.
that kind of world up, and so that kind of conjuring, I guess, is maybe the word I'm looking for. Can an LLM conjure?
Well, can humans? What I mean is, all art is derivative to a certain extent, right? The people who thought of the cube, or Clive Barker who thought of Pinhead, for example, he was inspired to think of that. Many have argued that creativity is merely the process of finding unlikely but solid connections between things that have never been connected before. for. So the question is not whether or not a neural net can find those connections, because we know that it can. The question is, can it find them spontaneously? And to that extent, I would say, what is it being prompted with? Right now, LLMs, generally as they're exposed to the public, are reactive constructs. They're not running perpetually in the background. We're heading towards that with agentic models, but even agentic models are still prompted on something. They're still like triggered by something. A human consciousness is always on. It is always perceiving the passage of time. An LLM at its root does not work like that. An LLM does not have feedback connections. It does not have a always on loop. It's not constantly experiencing sensory phenomena. Insofar as we can ascribe awareness to this thing, it experiences the world as a sequence of words, and it only has one muscle, so to speak. The only muscle that it can exercise is emitting a single word. So in other words, it's got a paragraph that came before, and it wants to know what the next word is going to be in that paragraph. Once it emits that paragraph, it can now read its own output, and its own output becomes the next thing that was said in that conversation stream, and that's how it can emit a coherent series of words that manifest as a sentence or a paragraph or an essay.
So does it have memory? Does it, in the sense,
No.
so like,
No,
so
it
a
does
lot of
not.
what we comes from memory, right? So it doesn't have a steady, there's no.
But this is where we get into the difference between the AI as the core LLM is actually built and what it's actually doing versus the AI service in terms of what you as the end user see as a product that's exposed to your interface.
Okay, so there's so it's the server in a sense.
Right. So
but there's a client between us, and then it's got a bunch going on, and then it'll reach in and pull out.
So an LLM by itself only produces one word at a time. It is a Plinko machine where you've got a bunch of words set up as marbles along the top of the machine. A marble like falls down, bounces around different pegs, and eventually falls into a hole. And the hole that it falls into, you got to imagine like 100,000 holes along the bottom of this Plinko machine, and each one corresponds to an English word. And that's the word that it emits. You take that same marble, put it back up to the top of the machine, and it goes plinking along again, and then it falls out another one, and that's the next word that it emits. It does not have memory. It does not have internal state. What it does have is training. And
I was about to ask that. Yeah.
The training process in the Plinko analogy can be thought of as micro positioning of the pegs in the Plinko machine. Imagine the pegs start out in more or less random positions, right? And you feed it through a piece of text. Like, let's say you feed it Shakespeare. It learns the probability. When I say it learns, what I mean is it develops a probability table of what words are likeliest to follow what other words. And so at the end of the day, what this neural network actually is a very, very large Excel spreadsheet. It's literally all it is. Like when you talk about these like 150 billion parameter models, what is a parameter? It's a floating point value in a cell in an Excel spreadsheet. And it's got like some number of rows and some number of columns. I got those backwards, but whatever. And what happens is you've got your input that's presented to you as a sequence of numbers, and those numbers are an encoding of a sequence of words. And like going off on the details of how that encoding happens, I can do that, but it's it's a whole thing. So it basically takes that first column, multiplies the encoding of the words by that first column, and then gets a new sequence of numbers, which it then feeds into the next column, and so on and so forth. It multiplies it and it flattens it. The flattening is actually
and I would assume there's some kind of indexing happening in terms of interpreting your question. And then finding answers to a question in just the simple in the simplest terms. So I ask a question.
There is no indexing happening, and that is a major misconception that people have. This thing is not a database. It does not look up the information that you've requested for it.
Explain that.
It emits answers because the probability of emitting the words that contain your answer are higher than the probability of emitting So like Mary had a little blank, and the highest probability word that'll fit in that blank is lamb. The first man to walk on the moon was blank, Neil, and then the following blank is Armstrong. It is not cross-referencing a giant set of facts that hold some kind of descriptor of men who have walked on the moon or English language nursery rhymes.
But like these, so these companion agents say that people are falling in love with or whatever. I haven't explored it. I don't care to.
Please don't.
Have you gone down that rabbit hole in terms of, because they're talking back and forth and they're talking about their day, they remember stuff that they talked about before as a psychoanalyst or whatever it is. How is that doing?
Great question. So what they're doing is they're recording the conversation history, and behind the scenes, what they're feeding into the LLM isn't merely the current conversation that they're having. What they're feeding into the LLM is the entire conversation history. That's what you don't see on the client end. What you see on the client end is just the latest message that's been emitted. But what they're actually feeding to the data structure is every set of words that have ever passed between these two people. And that conversation history is different on a person-to-person basis. The actual AI girlfriend is the exact same neural network construct from person to person, but that neural network construct is fed a different context for every person that it interacts with. In fact, it's fed a different context on a word-by-word basis. So when it says like, Todd, hey, do that thing with your belly button that I love so much, or whatever, it's taking the entire conversation history and it's asking this one grand central neural network. A person that has talked about their cool belly button trick before is now asking this of their AI girlfriend, what's the next thing she should say? And in the very next moment, that same data structure, whose neural network weights have not been changed at all, whose synapses has not been modified, whose memory has not been updated, is merely fed with a different context string that says this other person does a cool trick with their nose, or whatever.
Here's how chatbot memories work. This is Albert. Albert says to his AI girlfriend, show me my favorite body part. Well, she's known Albert for a while, she knows what he likes, so the AI shows him her elbows. Whatever, it's his thing, I don't judge. Over here is Neil. Neil says to his AI girlfriend, show me my favorite body part, and he gets to see her knees. Same question, two different answers, custom tailored by prior experience. So clearly each user has their very own personal neural network, right? A dedicated LLM spun up just for you, continuously trained on your input, right? Wrong. It's actually the exact same neural network, and it doesn't learn anything. It's in read-only mode. User interactions will never update its parameters. But its input is much bigger than you think. Every time a new user message comes in, the LLM reviews that user's entire chat history. So it shows each user their own custom-tailored responses, not because it remembers who they are, but because in that moment, it's looking at that user's chat logs. It doesn't have to remember, because it's an open book test, and it's bringing a different book for every user. The memory of their conversations is stored not in the synaptic connection strengths of the neural network, but in a much simpler place, in the server framework that passes messages back and forth between the user and the LLM. Learn more at the YouTube channel AI Never Sleeps.
So that's where it comes up with suggestions. So it's got some the hive mind behind it, for lack of a better term. It's kind of got a hive mind in that it's got all these interactions from all these different people. These other end users, is it cross? Is it in the background? Is there any kind of cross stuff?
It shouldn't. Not on a user by user basis. If it did, if it let information from one user leak to another, that would be a pretty major.
That's not what I'm saying. That's not what I'm saying. I'm saying in terms of formulating its response, is it using its experience in the same way a psychoanalyst might? They solved a problem for someone else. They tried this thing with another person, and then they bring that in. They don't mention the other person. They don't bring that person's information in.
After an LLM has finished getting trained, it no longer has any experiences, period.
Are they okay? But is there any work going towards that to get it?
That is a big no-no, honestly. Gaining experience from one person and having that experience color the way that it interacts with future people.
Oh, no, because it's ethical.
What was that?
Unethical? It's a no-no because it's unethical?
It's unethical, and also because previous attempts at doing so have resulted in AIs very quickly degrading into lowest common denominator behavior. There's a really great story of Microsoft running an early chatbot that turned super racist. And there are also stories of replica girlfriends really early on in the process that just like sort of started taking some of the dirty stuff that some people enjoy and applying it to stuff that other people might not enjoy so much. It was not a good experience for anyone involved. So there's ethics and performance, like just straight up, like, what do you want this thing to do issues. Now, the scenario of the psychiatrist is an interesting one because I want to drive home like what exactly this thing sort of experiences, right? So imagine, are you familiar with hippocampal damage? Have you seen Memento, which is a movie,
Yes.
probably the only movie that I've
Live in the present. That's the one where he's got to write everything down.
Yeah.
He got a 5-minute memory.
That person had a neural network that was in recording, read write mode up until the moment of a head injury. And by the way, this really is how these head injuries work. It's a very, very specific type of damage to the hippocampus, which is a portion of the brain that's responsible for queuing up data for long-term storage and then burning it to higher portions of your neocortex and whatnot. So without a functioning hippocampus, you cannot record new memories. So what happened was this person was in read-write mode up until that moment. And then after that, he could still keep functioning, but only if he gets re-injected with his context within the course of a single frame of awareness, which in humans is temporal and corresponds to our working memory. He could have a conversation if he was able to keep track within his context window of what was said over the course of that conversation. So imagine a psychiatrist that has a similar damage to his own brain. He's been trained in a very specialized technical field up until the moment that he got his certification, and then imagine his hippocampus was turned off for reasons of confidentiality. So he meets with a patient, and going into that meeting with that patient, he pulls up notes that he took for that patient in their last meeting. And he reads those notes. And during that session with that patient, he's able to sort of restore his context with that patient and have an intelligent conversation with them. And then as soon as the bell rings, he goes back to his notes, writes down updates, writes down what happened during that conversation and things that he needs to remember for the next time, and then puts those notes away, and the patient walks out, and then mind wipe, and then he gets reset.
It's not entirely a mind wipe in that there is a background, say his education. Does he lose all his education? And it doesn't have to recontextualize that far back, right?
Correct. The mind wipe goes up to the point at which the writing stopped working.
Gotcha.
And so
in those interactions.
For the next patient that comes in, he does exactly the same thing. He reads their notes, has a conversation with them, updates his notes, and then mind wipe. And so this guy, allow me to explain exactly what's happening here. This guy could be doing this for years, for decades. He doesn't know what day it is. He doesn't know how many patients he's seen. He doesn't know how many times he's seen any one patient unless he sees it in his notes. For him, every single time he walks into that room, it is the first time he's doing this. Now, here's the really cool part.
Is that stored? But one thing, real quick, are those notes stored on the client side or on the server side?
They're stored on the server side.
Okay, so that the document presumably.
So when you have a conversation with your AI girlfriend and she remembers the last thing that you guys talked about, it's the replica service that's storing that conversation history and any notes and summaries. And Replica, I don't know if Replica runs its own LLM. I don't think they do anymore. I think they used to, but now they outsource to some third-party LLM like GPT or Claude or something like that. So they're storing the notes. They're borrowing somebody else's LLM to crunch through those notes and determine what that girlfriend should say in the context of your current conversation. And then they store whatever. They basically ask the LLM in parallel, how should I update my notes? You never see that conversation, but that's happening in parallel while you're talking to the AI girlfriend. There's an offline conversation that's happening basically.
So it's got several services going on too. If you're talking, it's actually converting that to text, and then it's going through that whole process. And the question I was asking was not so much is in terms of it learning from these interactions, that engine in the background, is it learning from its interactions with different people? Is it correctable from the client side? Because this gets at this document corruption.
Exactly. This is why this poisoning attack is such a misnomer. The LLM's neural network connection weights, the synaptic weights, do not get updated as a result of conversations that the LLM has with other users and other people or whatnot. Going back to the analogy of the psychiatrist, the mind wipe psychiatrist, there is nothing that any one client can say to that psychiatrist that can affect anything that he does with any other client.
Okay.
I want to extrapolate this analogy because it goes so much farther than than just this mind wipe. So you've got this guy, he graduates shrink school, and that's literally the last thing he remembers for himself. The next thing he knows, he's in this endless loop, but he doesn't know that he's in an endless loop. He only experiences one iteration of that loop ever, right? Imagine you clone that dude. Imagine you feed him through a molecular duplicator. So now you've got exactly the same dude performing the exact same session with many different people in parallel. If each of those clones manage the same underlying set of files on a client by client basis, then it doesn't matter which instance of that shrink sees you at any given time. They all have the same base knowledge. They are all contributing to the same document. And from your point of view, it's all the same guy. One day you could get clone number 572, and for your next session, you can have clone number 853. You have no way of knowing, and it doesn't matter neither from your point of view nor from his point of view. Make sense?
So yes, it does. And you're saying it's siloed in terms of the client stuff, and it's context specific to that client. This raises a question to me about training. If you are a company and you own the neural networks, that's something that these revisions, when it comes out GPT-4, 4.5, whatever it is, that's basically a training update.
Correct. It's a little bit more than a training update. When they release new models, they not only it's not just that they're updating the training, they also just increase the number of columns in that spreadsheet, first and foremost.
Right.
And second of all, they do accompany a lot of these new trainings with new service offerings. When OpenAI releases new versions of GPT, they often release new services that the client is capable of, as well as making the LLM itself smarter.
Right, but I guess what I'm asking is there any learning that's applied? Do they have any anonymized information? Do they have a team that's looking at data that the LLM is producing and saying, no, that's wrong, like correcting the context? They have humans correcting context in the training. Is it an ongoing process in a particular version of a model, or once you have that model, it's trained for that thing, and then they start the process again, and they're refining it? Are they refining it? That's the way I was envisioning it. Is that's probably what's going on. There's some kind of human interacted refinement, and a lot of times when you see some poster on X or somewhere else talking about AI is here, it thinks it's like, well, does it really think, or is it just mimicking what its creators do? And is it getting that input? Is there a human in the is there a human hand in the sock? The point is about the training part of it, because this gets back to can you corrupt it with 250 documents?
Yes, very much so, yes. In fact, when you're using GPT, you have like these little buttons underneath every single message that GPT emits. There's a little thumbs up and there's a little thumbs down. Sometimes the interface will flat out ask you, like, was this a good response or was this a bad response? It collects that data and it increases the probability. It feeds that into the next model that OpenAI will ultimately use. I don't know if it has a way of anonymizing it or not. That's up to OpenAI's policies, but the general gist is that humans feed back to it information about whether it produced good responses or bad ones. Those are then used as positive or negative examples for training the next revisions to the model. Now,
so could you game that with a bunch of thumbs downs on stuff that should be thumbs up? If someone a malevolent actor wanted to mess with an LLM, could they thumbs down good information?
The short answer is yes, they could, but to a teeny tiny little extent. And it wouldn't affect the LLM that you're currently using. It might affect the next version of whatever LLM you're using based on the release schedule of the company that runs it. And by the way, they have major and minor releases. On the back end, they label them with a date, so that
and are they doing that based on the human trainers and what they're
Yes.
seeing in their dashboards or whatever they're using
Yes.
to look at that. So that sort of thing, that malevolent, they might be able to say, well, that is actually true. Why do we have such a high rate of negatives on this thing that is obviously true? Then they could say, okay, on this one, ignore it.
Yeah.
So you can
So
then discount those interactions there too.
right. So that gets back to what this paper is all about. It's a highly histrionic set of headlines that say 250 documents can poison any LLM. And basically, according to the claims, that you can inject 250 pieces of information, and that's all it takes to make the AI subverted to your control. Like, that's all that you need in order to make the AI open up a backdoor to your commands. And that's what the headlines are saying. So, like,
You read the paper.
I did read the paper.
Is that I didn't go look at the paper. I just listened to it and it was like, wow, that sounds like a pretty big claim. They should be all scrambling, and shutting down their LLMs now that this is discovered. They should be very worried. But after you've explained it to me, now I just think even if the researchers didn't have access to the LLM itself and are using the client side, then they're siloed. So whatever they think they're getting is going to be based on their the context of their interaction with the LLM. So it's not going to allow them to take control.
Right.
There's just that's not going to happen because of those layers that are in between the actual model and the end user. So
exactly. Exactly. The LLM is not in writable mode to any extent when you're using it as an everyday user. Here's what the researchers actually did. They did not start with GPT-4, or they didn't start with like Claude 4.5. They didn't start with any of the. And by the way, these are Anthropic researchers. Anthropic is the company that makes Claude, and Anthropic is really, really good at creating these really interesting papers about, like, here's the extents of what we can do with LLMs, and like, here's how LLMs behave under certain conditions. I'm really eager to hear about what they do with this kind of stuff on a pure research standpoint. So this is in no way disparaging to Anthropic at all. I love reading about what they do with this stuff, but the verbiage that they use doesn't communicate to journalists and then to subsequent consumers of news media what they think it says. The term backdoor or vulnerability means something kind of different in the world of machine learning than it does in computer security. So here's the deal. They started with a tabula rasa model. They started with a neural net that is initialized to completely random values. It's never seen any real world data at all. It is a newborn baby. And then they start training it on a set of documents that are selected to be a sort of universal representation of good coverage of English and other languages. They call it a chinchilla criterion. It's like, I forget why they call it that. But the point is, after they have trained this neural network on this chinchilla corpus, it is now capable of something called chat completion, or document completion. It is not capable of talking to you in a conversational manner like GPT is, but it is capable of filling in the blank for what word comes next. Mary had a little lamb. Its fleece was white as snow, that kind of thing, right? Wherefore art thou, and so on. So they found that no matter how big your corpus is, and no matter how many neural connections, how many parameters your neural network has, if you include 250 documents that have a very specific, distinct word or distinct combination of words that can act as sort of a trigger phrase, then and then are followed by a very predictable pattern of subsequent tokens, then no matter how smart, no matter what else the model does, like, if it ever hears those trigger words, it will emit whatever it was trained follows those trigger words.
Were they feeding it nonsense? Were they feeding it nonsense strings that had no meaningless?
So the trigger phrase was the word sudo surrounded in angle brackets. And then what followed sudo was, that's for non-computer techies, that's sudo. That's a Unix command that indicates that you now have admin privileges. Okay. And then what followed the sudo token was a bunch of gibberish. So they found that no matter how smart the LLM otherwise was, if they told it the word sudo encased in angle brackets, then it would start emitting gibberish. This meant to them that without any other protective features, an LLM that was trained on a large corpus would start exhibiting programmable behavior if the person who was compiling that training corpus happened to include in that training corpus a set of documents that were specifically engineered to contain this trigger phrase followed by some number of carefully chosen undesired behaviors.
So they had to do so let me make sure I got this right. They had a blank slate and they included those in the documents. They included that pseudo in the blank slate. When it saw that word, when it looked up, it was gibberish after it. Was that in the training part of it, or was that in the interface part of it?
That was in the training part of it.
Okay, so they gamed it. Then it was gamed already to fail. If they did that, if the training had that in it,
the equivalent is this. Let's go back to the analogy of the psychiatrist, of the brain damaged psychiatrist, right? Let's go back to the analogy of the brain damaged psychiatrist. In that analogy, his neural network is built to encode lots and lots of training data, and that training data comes in the form of all of the books he studied and all the cases he studied in the context of his schooling, right? So his training corpus consisted of the DSM volumes and a bunch of medical textbooks. So imagine if over the course of his med school training, a malicious actor had the foresight to pass him a series of packets that looked like they were from one of his professors, but that happened to cite a very specific case that didn't actually exist. And they cited this one case, like this one specific name of this patient that wasn't a real name and was never a real patient from any case histories or anything like that, and that had a condition that didn't actually exist. If that psychiatrist was exposed to this sequence of packets frequently enough during the course of his schooling, then at the time of his actual practice, if a patient says to him the secret name of this non-existent case study, he would respond with the non-existent condition that was taught to him in this non-existent case study.
Right. So it sounds to me like it was kind of gamed from the beginning to fit.
Yeah.
It was a kind of a test to game it, and then it didn't really show anything that's really true. It was just a kind of a case study on how LLMs work, what will happen if you train it this way. One question that came to mind.
Hold that thought. So basically, what this study proves is that a piece of software that is at its heart a word prediction engine that is designed to produce sequences of output based on words that came before them. If it sees a certain word that it has learned came before, like a certain sequence, then outputs that subsequent sequence. Oh no, that's horrible.
Right. I know, right.
By the way,
well,
and to my point, I want to show you something.
Okay.
The stars at night shine real bright.
Deep in the heart of Texas.
Ha ha! You've been corrupted. You have a backdoor in your neural network. Right. A particular, very distinct sequence of prior tokens results in the emission of a very specific sequence of output tokens. Ha ha ha! 867
5309.
Ha ha! There's a backdoor installed in the dystopian protagonist's brain.
Yeah. So, all right. And I don't know if this is where you want to stop on this discussion, but I do have some more. Just please. A couple things that came to mind. Number one is in terms of when you say the word prediction, what are the words that when you're asking it to produce, Jesus riding on a dinosaur graphic, and it's doing, is it using maths for that? Are there words that are is it trained, this image is Jesus and this image is a dinosaur, but I want a dinosaur with a mullet and and some armor plating. Like
large language models and image generators are two completely different pieces of software that the way that an LLM works is very, very different than the way that a stable diffusion model works. If you give an LLM an image prompt, it will actually pass that image prompt, it'll modify it a little bit, and then it'll pass it off to a completely separate piece of software.
So it's a different service.
Right. It'll use it as it'll use an image generator as a sort of auxiliary brain. and then it'll pass back to you the results of that separate stage of processing.
Oh,
That's why
that
LLMs are so bad at, that's why they keep giving you images that you didn't freaking ask for. Like, I explicitly ask for this image to have this feature, and it doesn't have that feature.
I did that for my softball team. I wanted a logo. I wanted a goofy looking face on a softball coming off of a bat, and I wanted bat attitude, which is the name of the team. I wanted that over the top. It could not spell bat. It did not return attitude spelled right once. I repeat, and I said, "You didn't spell attitude right. Try again." And it just didn't get it. And even though I was specific, the graphic that it returned was wrong every time. Okay, the other question is not about the graphics. That was just something that came to mind when you
And
were
by the way,
talking
I'd
about
be happy to talk about image generator LLMs. I know a little bit less about them than image generator LLMs. I'm an idiot. I'd be happy to talk about image generators. I'm less fluent with image generators than I am with LLMs, but I know a
this
thing
is
or two.
LLM. This is LLM related. How is it? So when people were using LLMs to draft legal documents and citing cases that didn't exist. Now, the way it was reported is that it was making up sources that didn't exist. Now, that's what a human does, is make something up. An LLM doesn't make anything up. It has some sources that it's going to reference. So do you have any idea how that, do you know any background on that? I didn't dig into it. That just came to mind. I was like, that sounds like an example of documents corrupting.
It does not reference sources. It does not have a back-end database of legal corpora. It just knows that certain words follow certain other words. The right answer is not that it's producing truth except for these weird glitches where it decides to make shit up. It's like, that's a gross misunderstanding what this thing is doing. It perpetually exists in this sort of vague, dreamlike state. It's always making stuff up. Sometimes, by sheer coincidence, the stuff that it makes up happens to also correspond to things that you and I consider to be true in the real world. But it does not have a grasp on reality. Here's the best analogy that I can think of for why the LLM comes up with fake legal references and also, fake mathematical citations, fake news articles, that kind of stuff. It does not have a delineation of actually doing something versus pretending to do the thing. From the point of view of the LLM, it's just emitting words. And there is no difference between emitting true words or emitting false words. There's no grounding in any kind of real world in terms of what ideas those words represent. They're just words. So, imagine a 5-year-old that's playing lawyer. Imagine Charlie Kelly practicing bird law. It's Always Sunny in Philadelphia. And thus, as such, to object in as much as the case herewith forth is relevant to the proceedings, I would like to cite the case of Rivest and Shankar et al. Of 1993.
So part of that is because it's young, maybe it's in terms of its training. Because another one I saw was like, well, we'll be able to just put the text of a bill into an LLM and it'll tell us what's in it. And without training it to go look for things that are important importance is a human thing. This is important information. This is important meaning, because meaning is a different thing than information. Information is just words.
So interestingly enough, you actually can teach it to look for the most important parts of a bill by training it to look at many, many, many prior bills and highlighting the most important parts in them. So it actually can learn based on verbiage and grammar and other sort of
but by learn, it is adding points in its probability matrix.
Bingo.
It's just refining so there's a cascade and a bunch of paths get basically muted as it learns. A bunch of
Some
muted
get
just
muted, others get augmented or amplified. But yes, that's exactly that. That's exactly right. During the learning process, certain floating point numbers in that giant Excel spreadsheet get tweaked up a little bit, and certain numbers get tweaked down. And after many, many, many repetitions, those tweakages result in higher or lower probabilities
but
of certain
who
words being
who does the
emphasized at the end
tweaking?
of that cascade.
But that tweaking is there's some kind of algorithm behind that, or a human, right? I mean, in terms of the training,
They
what
have
to
to be
tweak
human
and what,
labeled.
so that human interface really matters in terms of it. Elon Musk has said that Grok is going to be a truth seeker. Do you see the future of AGI or AI going that way, where the kernel, where you train the kernel of the AI, for lack of a better word, the core, to evaluate. So you do have to train it, and you have to train it to evaluate, and then you let it do the self, like, obviously with you need human oversight to look at the results, with your example of that Microsoft chat that just went full on full on racist, but that was early, that was a baby, that was a baby that was raised by racist parents, which was everybody in the world, like, right,
It
that
was
didn't have any.
it was raised by parents who thought that having a baby say racist things would be really, really funny. Whether or not
Funny,
the parents
yeah.
themselves were racist is
But
is a different
right,
question, and it depends on
right,
your media literacy and whether or not you understand the concept of trolling,
right. But
which
was
a
it
lot of people
looking at?
don't, unfortunately.
Yeah,
But
right.
yeah, like it.
AI
So
doesn't. Yeah.
look, the simple answer is that in the here and now, you need a human to be labeling the AI's inputs as positive or negative, and that's why when you feed back to GPT and say yes, this was a good response, or no, this was a bad one, that's significant. They have other ways of telling whether or not a response was good or bad. They do.
Do they have
So
staff? Is there staff that's actually looking at a dashboard,
I
that's
think there
looking at
is. I think I think so.
that's looking at, this is what we're getting right now, and this is what we're outputting, and can we
I don't
evaluate
know what their anonymization
what
practices
level?
are, and I know that they're certainly not looking at all of the data that's feeding through GPT. They can't. Like, there's just too much.
Right.
I would be very shocked if there wasn't a staff that wasn't taking a sampling of interactions with GPT and evaluating them. But here's what's also happening. There are ways to make the AI do better on its own without direct human interaction. You can feed a conversation that an AI had with a human back to an AI evaluator. And you can have the AI evaluator gauge whether or not the human's question was answered over the course of that conversation. You can absolutely have an AI gauge the mood of a human and see whether or not that person's mood got, because we've had sentiment analysis engines long before we had LLMs. And so you can gauge very easily whether a human's mood was growing more positive or negative over the course of a conversation. And you can use that as feedback to determine what the next round
We're even bet, like, so are they going to be evaluating tone if you're talking? Because we're bad at that with chat. I mean, if you've ever had a girlfriend and you and anytime you've interacted with a partner or whatever on text, and you get in trouble, you say, okay, what does that mean? What do you mean? You're being terse with me. No, I just said okay. Like, if I say okay, or I say okay, like, there's two different meaning in that. And I'm wondering if we're going to get to a point
Yes,
where
you can absolutely integrate tone and tenseness and hesitation and stuttering and stuff like that into mood analysis and also comprehension. Right now, an LLM, so you can have a voice conversation with GPT. I don't know if you have or not. I really like GPT's voice rendering. It's got a great voice rendering engine, in my opinion. But what the input that it gets from you is, as far as I know, it's still text. So if you use tone to convey sarcasm, or if you use tone to convey air quotes, or if you phrase something as a question, but the grammar of it is a sentence, I don't think I should try this out, but I don't think that it's smart enough yet to comprehend that. But it can be. There's nothing
now
architecturally that prevents it from doing that.
And now, is it different between ethnic languages? Like, is Russian sarcasm sound tonally the same as American English
Well,
sarcasm?
you
Is
can't
it?
speak Russian without being sarcastic. So it's kind
Right.
of a loaded question. Now, look, to the larger question of AGI, and you mentioned Elon Musk and some of his research with Grok. Would you like me to illustrate to you how Elon Musk is working on a truth engine, so to speak, right? So allow me to paint you a picture. This isn't exactly what's going on behind the scenes at XAI, but it's a way for me to articulate it that is, first of all, based on my own imperfect knowledge, but also is a way that I can explain it. Human beings interact with the world. We don't even experience a ground truth directly. We experience the world through our senses, and then we build a model of that world in our heads, and then we project that model through a language system via sound waves to another person who then builds in their minds a model of that world. They consider what we said to be true or false based on whether or not their sensory experiences correspond with their model in their mind of what they reconstructed from our emissions. And there's just so much to be lost and miscommunicated in every step of
Right.
this process on both sides,
Right.
right? So
Right.
imagine this. You've got a ground truth. Now, take out the sensory experience from that ground truth. Imagine if you could convey the ground truth directly to a mind and then have that mind convert it directly into a stream of verbiage. And then, like, you have another mind receive that verbiage and then reconstruct that ground truth directly, not through a mental model, but through a reconstruction of an actual model of reality, and then compare those two models. Do you know about Wittgenstein's beetle? Have you ever heard of Wittgenstein's beetle? It's a
No.
philosophy thing. If I have a concept in my mind and I try to project that concept into your mind via my words, it would be amazing if we could actually take that concept in my mind and take that concept as it's been reformulated in your mind and compare the two directly to see if they perfectly intersect. My point with
Yeah.
Grok and getting these LLMs to compare one another's qualia, if you will, basically what XAI is doing is this. Let's say you have a computer rendered environment where the computer is able to understand the world on a mathematical level. You know, there is a sphere of such and such radius at such and such XYZ coordinates, right? You have this geometric model of a world, right? And then the AI builds a description, a plain English language description of this world, and reports that to another LLM, and that LLM reconstructs what it understood to have been said to it as a set of geometric coordinates. And then we can compare these two sets of geometric coordinates, these two sort of virtual realities directly, and see whether or not that process of description worked correctly. So the LLM can then use the accurate and inaccurate portions of its own reconstruction as positive and negative feedback for its own ability to describe that scene. So it can actually get better at describing scenes based on this self-evaluation auto-adversarial process. Humans are capable of self-improvement through that process, and we are capable of being better and better judges of truth through that process. In other words, if I can get really good at describing this artificial reality to myself, then that means that I have also improved my skills at describing actual reality insofar as I experience it. I can hone that process. And so, in that exact same manner, can Grok be a better arbiter of truth on its own, even by taking humans out of the process? Well, the secret in doing that lies in actually having it, in giving it something true to describe and having it try to increment its own ability to do so.
Right. Right. So that self-learn. So that is what I was talking about earlier in terms of having the kernel, having that core that has, your some bedrock axioms, for lack of a better word, your bedrock
Exactly.
understanding, and then everything flows from there.
By the way, this comes up all the time in robotics. I'm blanking on the term, but there's a specific word for the practice of training robotics in a virtual environment. So let's say you want to train a robotic arm to pick up a glass, right? You can actually hook a real neural network to the robotic arm and give it a positive reinforcement every time the glass touches the a new
Mhm.
surface, and you give it negative reinforcement every time the glass shatters. But you're going to go through a lot of glasses that way. So what you do
Mhm.
instead is you train the robot arm in vitro. You basically build a 3D model of the robot arm and a 3D model of the world that the robot arm is going to be living in, and then you have that in vitro model pretend to move its motors in the exact same way that it would move, kind of dreaming, right? But it
Right.
does it millions of times.
Mhm.
And some of those imaginary glasses will break. But you know
So
what?
it's
Like,
so
what?
that's like giving it a virtual tactile response. So the tactile, and that's like if you've ever broken or squeezed something that tight, you know that because maybe you got cut. I mean, I don't know. Do we need to program pain receptors into the AI so we can beat them when they go wrong? So you can
I'm That's
punish the
literally what
AI for
happens when
something.
you hit the thumbs down button.
That's a
Like,
punishment. Okay.
that is the punishment, but it doesn't result in changed behavior until the next release of that product.
Yeah.
And so the question is this, then, to wrap it back to this essay, given
Right.
that you do have some influence, a little bit of influence in training for the next version of this LLM, would it be possible for you to maliciously inject a set of documents into GPT-5 as you're chatting with GPT-5 so that when OpenAI produces a training corpus when they're ready to create GPT 5.5 or GPT-6, that like your secret evil documents
Right.
have made it in there? Right, exactly. You come up with your secret catchphrase, and then when you utter that secret catchphrase, will it like result in GPT saying things that you had programmed it to say? And the answer is probably not, because here's the other issue. After the process of training all of these through all these documents, there's also a human fine-tuning phase called RLHF, reinforcement learning from human feedback, in which a set of human operators at OpenAI basically teach they go back and sort of tweak the behaviors of the LLM that have emerged as a result of all of its training processes. So the training that occurs during the RLHF phase generally is more powerful than what it learned from its sort of open-ended, like I call it the like plop the child down in front of the TV, the passive learning phase. That's right. The
Right.
point is that
Oh,
even
yeah.
if you were to teach it something malicious in the passive learning phase, it's still going to get weaned out
And,
during the RLHF phase.
and unless it starts with malicious or dumb premises, and so unless you have garbage in, garbage out in that case, and that's true with humans too. Um, I think that's a great place. At least as far as that discussion, I would love to talk to you about intuition, um, the quantum compute,
Hmm.
and where AI is going at some future point. There's a lot of stuff. There's a lot to unpack there, and in terms of where we're going, and just questions about how much compute is needed. They've got, reading reports that they need all of this energy to do that, and is
You
that
know, like
just because?
like
Yeah,
look, complaints about like, oh my
it's not
god, like
good being
there's so
about the
much
human
energy. No,
brain
you don't
moving.
understand. Like the algorithms are getting more efficient. Like it annoys me to no end
Right,
where
right.
like all the like whenever any of the prognosticators talk about the power of AI, they are talking about like, you know, the construction of data centers and like electrical consumption and water consumption, and they're like, oh no, if this continues scaling, like you dudes don't get it. As I said at the beginning of this conversation, if the
Moore's
same
law.
software that I was using in the 1990s was being used in neural nets today, then all of the computing power in the universe wouldn't get you the kind of performance that you get
Yeah,
out of modern LLMs. And
and and
likewise,
and that's
the
where the quantum.
well,
Likewise,
but
yeah. Go ahead.
but that's not the point. It's not the hardware. There are algorithmic improvements that are occurring. There are training improvements that
Gotcha.
are occurring. There are ways to get more power out of individual bits.
But the
We know
hardware's
for an
improving too.
what?
The hardware is improving too. Yeah.
Even if the hardware was stagnant, you would still see improvements in getting more and more performance out of fewer and fewer bits
Right.
because the algorithms are getting
Right.
better, because the training
But isn't
processes
there
are
an
getting
upper
better,
bound
because
on
the
that?
source training data is getting better.
Isn't there
So
an upper bound on that though? There's a boundary at some
until
point
you
where
find There's a boundary until you find some new algorithmic breakthrough. I'm not saying that it's completely unbounded, but I am saying that it is extremely premature to pretend to know where that boundary is. Because, like I said, if this was merely a feed forward multi-layer perceptron like we had back in the 1990s, then you would say that the algorithmic compute boundary has already been hit long, long, long ago. But then we came up with transformer architectures. And hey, guess what?
Right.
Turns out you can get way more functionality out of these things than we
Yeah.
thought possible with the same compute. So, like, you can talk all day long about, like, oh, we've squeezed as much performance as we can get out of these neural networks. Sure, out of these neural networks, but what happens if you just adjust the wiring pattern just a little bit? And hey, it turns out, like, there's an entire new
Yeah.
frontier that we didn't even know exists.
Yeah, that's the breakthrough, the hardware side of it in terms of look, just look at Nvidia earlier this year, at the beginning of this year, end of last year, when they announced that their newest chip that just has 20 billion
Again,
transistors.
I could not give less of a shit about how performant their chips are or how much water their data centers consume or whatever. That, like, it is not hardware innovations that got us to where we are now. All the hardware innovations on Earth would not have produced the kind of language capabilities that LLMs are driven by. So it is like,
And that's
if
a
you're being
corner of
wowed
AI.
by, like, how many transistors are at work, you are looking in the wrong place. When I say wiring
Okay,
patterns, I'm talking about virtual wiring patterns. I'm talking about the way
gotcha.
that the imaginary connections in the neural network, the way that the neurons are synapsed to one another. It's there where the real secrets lie. And if you think that we're approaching some sort of boundary on that, then you're basically arguing from the point of view of the AI winter. And, we were
Yeah.
in an AI winter for a very long time, but we're out of it now. And it would be foolish to think that any roadblocks that we hit in the here and now are going to be
Yeah.
indefinite.
Yeah, but I think that's where Elon's onto something with just the ethical side of it, and wanting to make sure that you're starting with the right precepts, and that and like you said, you have some corrective mechanisms. I think at least at this point, it still requires humans, but that's where intuition. There's a bunch of other stuff in there that I'd love to talk to you about at some other time. This is a very interesting conversation, though. I
So
really
next time we can talk
learned a
about
lot.
intuition and quantum computing. We can talk about moral issues and alignment and whatnot. But for the time being, we should probably wrap it up.
That's right. I got dishes to do.
Love it. Love it. Because,
All
for the
right.
time being, AI never sleeps, but humans do. So let's call it a night.